Okay, so um, this question is you have the hydrogen fluoride solution. You know the pH of the hydrogen fluoride, which is 3.65. And the question asks you about what is the concentration of this weak acid. Of course, it gives you the Ka, which is about 6.8 times 10 to minus 4. So first, what we can learn from this um, information is the pH, right? If we know the pH, we can easily know that the concentration of the proton in the solution. So that is 10 to minus pH. So that's equal to 10 to minus 3.65. And that's equal to about 2.24 times 10 to minus 4 more. And of course, we want to know the concentration of HF. So how should we approach that? We need first, right, to write down the chemical equation and draw the IC table. So let's see, if you had hydrogen fluoride, of course, will undergo dissociation to form proton and the fluoride ions. So we want to know the concentration, but we don't know, right? We can assume initially you have a concentration as C of the hydrogen fluoride. And of course, before the um, dissociation, you don't have any protons or fluoride ions. And then you will dissociate to reach the equilibrium. So there will be a change, right? So what is the change? We can see the change is x, right? So there will be x of the hydrogen fluoride be dissociated. So if there's x HF be dissociated, it will generate, right, at the same time, x proton and x of fluoride. So in the end, you have C minus x, right? C minus x of the hydrogen fluoride and x of the proton and x of the fluoride in the final solution, right? This is the end. And now we already learned that we now know the concentration of proton. So this x, right, the x here is actually equals to the concentration of proton. And that's already calculated 2.24 times 10 to minus 4. And which means the concentration of the fluoride in the end, right here, is 2.24 times 10 to minus 4. So now the C minus x becomes C minus 2.24 times 10 to minus 4. So now the next step, what we can do is to express the equilibrium constant. For this reaction, the equilibrium constant is equal to the concentration of proton times the concentration of fluoride over the concentration of the hydrogen fluoride. So now we can plug in everything, right? It's equal to 2.24 times 10 to minus 4, since they are same, square, over C minus 2.24 times 10 to minus 4. And that equals to what? Equals to the equilibrium constant, which is 6.8 times 10 to minus 4. So now we can do the calculations. you'll find 6.8 times 10 to minus 4 minus 15.3232 times 10 to minus 8 equals to 5.0176 times 10 to minus 8. So the C equals to what? The C actually concentration would be equal to 5.0176 times 10 to minus 8 minus plus here 15.232 times 10 to minus 8 over 6.8 times 10 to minus 4. So that's equal to about 2.978 times 10 to minus 4 more. So that is a concentration of the hydrogen fluoride. And this is the answer. That's it.